Anybody remember what we did the last time?
Workers.
Say it again?
The worker thing.
Yeah, the workers. So we used a distributed task queue, even though ours wasn't distributed. We used a distributed task queue to put some work into a RabbitMQ queue, and then we had workers, processes that were sitting separate from our CLI application that would pick up that work off the queue and would execute it, and then would return the results to the originating process. Anybody remember what we did with that exactly? So there was a Hacker News API, and I could go get the top 500 stories on Hacker News, and once I got that list, I wanted to, in parallel, go out and hit as many of those stories as I could, pull back their JSON representation, and just print a couple keys out of that. So the idea was we wanted to split our work up so that we could get it all done at the same time and didn't have to wait in sequence for each one of those jobs to finish. Okay, so I was going to do some kind of riff on that today. I was going to keep going with that because I often like to build on the things that we've done, or at least kind of take one step away from them. And I started to try to do that again. I was going to look at different ways to parallelize that work. So last time we used Dramatic, which was a library that helped us interact with RabbitMQ and set up our worker processes. And this time I wanted to look at some other ways to do that, some other ways in Python to parallelize I/O work. In this case, the network, you could probably do it with the disk. That seems like it might be a little bit different, but you could do it that way too. So what happened is I started doing that, and a lot of my requests were failing to the network for whatever reason. I don't know if it was a problem with the network I was on. I don't know if it was some kind of problem with the Firebase system, but I was frequently getting, out of 500 connections, I was frequently getting it seemed like 10 or 15 of them that would fail. And because of the way that they were failing, sometimes they were taking 3 to 5 seconds to fail. And so it was throwing my timing off, because what I wanted to be able to do is I wanted to be able to demonstrate the different kind of performance characteristics of the different ways to parallelize this work. But when I had my own test, one taking 4 seconds and then the next one taking 14 seconds, it was going to be really difficult to figure out, it just wasn't going to be helpful. So that got me to a place, back to some things I did, I don't know, about a year ago, when I had to performance test I was having some networking difficulties, and I wanted to start performance testing various things in Python to get some benchmarks. I just wanted some baselines as to what the libraries I was using, what Python itself was capable of doing, because I was seeing incredibly non-concurrent requests when I should have seen a lot. So I was getting something like 26 requests per second in this particular application, and it was just killing me because I needed to be at 1,500 requests per second, which to me felt like it should be really easy, even with Python, even though technically Python is on the slower side of languages. And so I was really frustrated with that, and I didn't know where the problem was. So I didn't even know, I wasn't even sure, how does Python perform, period. And so I wanted to start with the basics, and I wanted to work my way forward. And I thought that would be a great example tonight to just demonstrate some of the performance characteristics of different things in the Python world when it comes to network and client servers and requests in the web world, so web requests. Questions about any of that so far? I realize I might have said some things there that maybe you don't quite understand. We'll hopefully talk about them as we go through. If you have questions, feel free to raise your hand. I love interaction. So if you have questions or I've missed something, feel free to ask me. If I feel like it's not helpful for the group or it's going to take too long to explain, I'll just tell you that, and I'm happy to answer that question for you at the end of the talk. Okay, so where does that leave me? So the first thing I'd like to do is I'd like to remove Python from the picture, if I can. I would like to have a tool that I know is going to give me good performance characteristics, so I can take the client part of the application out of the, when you're doing performance benchmarks, there's question marks everywhere. I don't know where the problem is failing. So I'm steadily going to work myself to a place where I can remove one question at a time until I figure out what it is I need to know. Because I don't know where to start, really. I might have some intuition if I'm experienced, but I still want, I may not know absolutes, but I'll start to get relative performance characteristics. So that's what we want to do. So the first thing that I realize is I'd like to take Python out of the client picture. So I'd like to not have a Python client. I'd like to have a client that I know is going to have good performance characteristics so that I can begin by testing my server. Because what I want to do ultimately is I want to be able to set up a server on my laptop because I want to remove the network even. Like I don't want to be testing Google, I don't want to be testing Amazon. I even tried Wikipedia and I had great performance at 50 requests and then I had terrible performance at 200 and I'm like, I don't know what they're doing. Are they starting to block me? Like, are they recognizing a lot of fast hits, which would make sense for a big, a big company like that they're, they may be blocking repeated, what look to them like abuse requests. And so I'm going to start with my laptop.
Wouldn't that also be similar to a denial of service attack?
Yeah, it could. I mean, at my scale, it's nothing like it, but it's kind of like that. Yes, it's more requests than a typical user would have, and so they start shutting them down quickly. So what I'd like to do is I'd like to build on my local laptop so I can take the internet out. I know that my local stack should be really quick in terms of the network stack, so I'm going to stay on localhost. If you don't know, localhost is just the term for kind of my local network IP address. So I don't go out to any network. I don't go on the local network. I don't go on the internet. I just stay right inside my kernel's network space, which for our purposes should be super fast. So I can make that assumption. My network stack is going to be, my local network stack is going to be really fast. Okay, so now I want something that tests that and just gives me a sense of how many requests per second can I make. Because remember, I was expecting, I was expecting to be able to make, in my scenario, I was expecting to be able to make 1,500. And so I'm just curious, like, what will Python give me best case scenario? Can I even get to 1,500? I think I should, but I want to validate that assumption. Okay, so the first thing that I'm going to do here is use a tool called AB. AB is from the Apache benchmarking, or from the Apache web server software. It's a utility that they include for benchmarking web requests. So that's great. That'll be my client side. It's C. It's tunable, so it gives me options for how much concurrent I want it. I know that it's built for benchmarking by people who are a lot smarter than me. I know that it's had a lot of testing, so I can assume it's going to do its job correctly, and that gives me my assumption that the kernel network stack is fast, and it gives me the assumption that the client's fast, and that allows me to test what then? What's left? Anybody following with me? I've got the client. The client's going to talk through the kernel network stack. What's the client going to talk to? Some server. So that's what I want. I want a known network performance. I want known client performance, so I'm removing 2 question marks, and that leaves me with just server. Now, granted, there's a lot of things we could test, but again, I'm just trying to get really rough benchmarks one way or the other, okay? So, the first thing I want to do is I want to build a web server. And, lo and behold, Flask has a built-in web server. So, I'm familiar with Flask, I'm going to start there. This code is in the, if you're interested, this code is in the Flog project. I haven't got it committed yet, but if you want this, I'll commit it probably later tonight or early tomorrow morning, just so that it's all there. And you'll see the commit if you want to look at the files that I added for this talk.
Where is the Flog project?
Ah, good. We have a DerbyPy GitHub organization, and there's a Flog repository underneath it.
Awesome.
That's a great question. Thanks for asking. Is that good? Yeah. Okay, so this is a Flask web server. It's very simple. I've got a single view. It's going to serve from the root URL, and I'm using the built-in Flask application right there. So this is all I need. This will give me a web server that prints out benchmark Flask every time I hit the URL. So let's activate that. Okay, benchmark Flask. Any questions about Flask web server? So I now have a web server running. Now I want to use AB to hit that and just see what kind of performance characteristics I get. I do have the README up here. It'll have some of those commands in it. I'll have them formatted a little bit better than this. So I'm going to flip over to a new tab. Now I'm going to start, the dash T is time, means I'm going to let it run for 5 seconds. The dash C is concurrency, so how many requests is it going to make at the same time? I'm assuming it's using threads. I don't know 100% for sure, but that seems like a pretty safe assumption. I don't know that it matters for our purposes if it is or not. But I'm just going to start with 1. So again, I've got some tunables here. I've got some things I can try, but I want to start with kind of the most simple scenario, and then I want to iterate on that.
How high can you make it?
You could probably set it to 1 million if you wanted to. I don't know. Nope. Invalid concurrency range. Looks like you set it to. It looks like you set it to 20,000.
Successful test failure.
Yeah, there you go. Yep. It's a good question. All right. Okay, so requests per second, 385 requests per second. So I happen to know, just because my experience, that's probably pretty low, all things considered. But it gives me something to start with. Now, if I was doing this for real, I would actually run this like 3 times just to make sure that each one of my runs was consistent. And if it wasn't, then I would know I've got something kooky somewhere, and then I would go try to figure out if that's there. But just for our sake here, I'm not going to keep rerunning them. But I would usually run these in groups of 3, and I would probably turn up my time to maybe about 15 seconds. And then if I was doing stuff over the internet, it might even be 60 seconds. So there's these parameters are tunable depending upon what you're doing. Okay, so I want to know now, so now I've got a benchmark for Flask. And I want to know, okay, is Flask slow or is the server slow? So what can I do? I can use a different framework, one that's made for speed, called Falcon, and I can just get a rough benchmark of what does Falcon do? Is it any better? Okay? Unfortunately, when you go to Falcon, you realize Falcon doesn't have a built-in web browser. It's going to force you to use a WSGI server. Well, now I've got some problems because Flask server is in Python, and Falcon is recommending that I use GUnicorn. So now I've got kind of a mismatch. Falcon also lets me know that you could use a different server that is Python only called Waitress. So I'm like, okay, that's good. So I can run Waitress with Flask, and I can run Waitress with Falcon, and I can get a sense of which one it's. So again, I'm just trying to get relative comparison, having as many of the same parameters as possible. So we're going to do that Flask one. So we're going to start with Flask. So we just saw the Flask Python web server was 385. Is that what I want to do? No, that's not what I want to do. I'm wrong. I want to do that here. So that was the Flask server that was running with the Python, built-in Python server. I don't know what it actually uses under the hood. I think there's a server in WorksHub. Okay, so now I've got Waitress serving the same Flask application. We had 385, remember? This is not feeling a lot faster. Oh, but hey, look, 529. Okay, so some of the slowness that we were seeing had to do with the Flask web server, not necessarily Flask itself. Okay, so now let's take the same test using the Waitress server, and let's run the Falcon application instead. So this is the Falcon application, different library, a little bit different way of setting things up. Still pretty simple. All right, let's pull that up. Great, now we've got Falcon 1. I did throw a little counter in there. I'm actually not sure if, is that thread safe? Do you know, Alex? Anybody else know if that's thread safe? That may not be the best way to do a global counter. No, he's saying no. So I don't know exactly what Waitress is doing under the hood, so this may not actually be safe to do, but for our purposes, it doesn't really matter. So it is working. The counter is increasing. And let's see what Falcon. So okay, so we had 529 was Waitress serving Falcon. Okay, and so now we've got 671. So probably a little bit faster. Now one of the things I'm wondering is, hey, I wonder how much concurrency matters here. So let's actually bump that up to 5. So we had 671 before. Normally I would be writing all this stuff in a spreadsheet to keep it all, to keep track of it all. Okay, so I got 936, so that's pretty good. I mean, that's maybe a 30%, 40% bump. So let's now see, knowing that concurrency matters, let's go back to Flask and see what Flask does with a bit higher concurrency. And let's see if that expands the distance between Falcon and Flask. Okay, 606. So it was, what was it? It was like 500 to 600, and now it's like 600 to 900. So that's a pretty big difference between Falcon and Flask. So if you, again, I should have made a caveat. Every benchmark, you're only going to get out of benchmark what you're testing. We are creating a very simplistic scenario here. We're not returning very much data, so all that stuff could matter. But again, I'm just trying to get relative performance characteristics of servers versus clients. And so that's okay for my purposes. Just be aware that this does not necessarily mean anything about what your real world benchmarks are going to be. If you really care about performance, you're going to have to find ways to do performance testing the same way that you run things in production. Okay, so what do we know? We know Waitress is faster than the built-in Flask web server, and we know that Falcon is better than Waitress, and we know that the best performance we've seen so far was 900 and some requests per second with Falcon and Waitress. So now let's swap out the server and see how much difference that makes. So now we're going to use GUnicorn, and we're going to serve Falcon, and we're going to use a custom worker class called MineHeld that's been built specifically for performance.
So you're saying there's an app for that?
There's an app for that. Yep. And now I had to do a lot more. It's not like I just pulled this out of nowhere. When I was iterating on this stuff, I was doing research about how to get faster performance in Python, with Python web servers. And so I had to do research to figure some of this out. We're benefiting from that here. I also did a bunch of research on how many workers here on the server side was optimum. And so we're going to get 5. We're not going to go through and test that. But I had to do, I started at 1, then I went to 5, then I went to 15, then I went to 50. And a lot of times with concurrency, you run into limits where when you add more workers, you actually hinder yourself because there's just resource contention then. So it doesn't help to set this to 500 or 50 even. Okay, so we're at 9 something. 9 something was Waitress and Falcon. So now we're going to see what Falcon and GUnicorn with the MineHeld worker gets us. And we noticed we didn't see any of those before, if you remember. We didn't see any of those printouts. So now we're at 13,000 requests per second. So we've 13x'd our performance, or a little bit more than that. So is Python slow? Yeah, depending upon what you're doing, it is. Now, I don't know this 100% for sure. I haven't gone and researched it, but I'm fairly confident based on my experience that that both G-Unicorn and the mine-held worker are programmed in C. That would be my bet. And so I don't know if they're doing it in raw C, if they're using something like Python, but just the performance difference I'm seeing, I'm really confident that that's what they've done. And it makes sense because they're both geared for performance. But you'll notice I still pip installed it. Oh, you wouldn't notice that because I did that already. But these things are both G-Unicorn and the mine-held worker are both pip installable. I can put them in a virtual environment. I can kind of deliver them wherever I want to in the Python ecosystem. I don't have to go get Nginx and set it up. I can just serve it. So again, if I'm serving 1 million requests per second, probably not going to work out for me. But if I just need something that's pretty fast for most use cases, this is probably a good choice. And I'm going to trade maybe a little bit performance where I don't need it for potentially easier DevOps, easier setup on my system. Questions? I have the link there if you want to do the Flask one, but it still just shows that Flask is slower than Falcon, so it doesn't help us very much. I'm not going to switch over there for time purposes. I am going to leave this running though, because now I've answered a couple questions. So if you remember, my goal was actually to test my client. Why did I spend time benchmarking my server first? Why did I set this up locally?
Wrap it out.
Yeah, so so now I don't have to worry about the internet. I know my server is capable of producing roughly 13,000 requests per second. So when I start benchmarking my client options now, if I'm seeing less than 13,000 requests per second, significantly less, I know that it's the client, it's not the server. If I'm consistently seeing in my client close to 13,000 requests per second, then I might actually have a situation where my client is performing faster than my server, and I might have to do some additional tweaking to see, well, can I get my server to perform faster? But again, especially with performance testing, has anybody heard the phrase premature optimization? Avoid premature optimization. So I could continue to performance test my server here to make sure I can get it absolutely as fast as it possibly can. But remember, I don't have any real idea what my client needs to do. And I know that what I'm seeing in the real world is like 26 requests per second. And so 13,000 requests per second is enough. It's enough to get me started now on the client work. I don't need to continue to optimize in this scenario. I have a good benchmark. It hasn't taken me long to get there. I now want to go target my particular problem a little bit more. Does that make sense? Is the way I'm thinking about this helping people in terms of kind of like go a little bit here, figure this out. Okay, I got a number. Go over here, figure this out. Oh, I got another number, and that bookends me. And now I can focus my time in the middle instead of spending the next day and a half going this way and the next day and a half going this way. Now it could be, if my client is consistently at 13,000 requests per second, I may actually have to spend a day figuring out how do I get 1,000 requests per second on my laptop so I can make sure that I'm benchmarking my client. I just don't need to do that right now. A little bit here, a little bit there.
If you just throw more hardware at it on the server side.
Yeah, exactly. Yep, I could, if I got there. Okay, any questions? How am I doing on time? Not too bad. Okay. So, last time we were here, last time I presented, we talked about the workers. We talked about Dramatic, and we talked about its ability to parallelize things. Dramatic, as I explained before, is the distributed task queue. It puts task in a RabbitMQ queue. If you don't understand what that is, that's okay. You can go Google it. Essentially, just think of it as kind of a really fast data store that's sitting on the side that you put an event in, and that event can only get pulled out. The way we use it, the event can only get pulled out by one worker. So I can put stuff in, and I can trust that those events are going to get distributed to workers, and then I've got workers sitting there ready to do those tasks. And because of Dramatic, the library, it's really easy for me as a Python developer to put work on the queue, and then have those workers sitting there pulling work off the queue. So in this case, what I want to do is I want to use Dramatic still. We're gonna performance test that. I want to use Dramatic, and I want to see how many requests per second it can accomplish. How many requests per second it can do against this local server that I've set up now. The dash P, so the script here, dramatic workers, just fills in some gaps, so I don't have to remember to always type a longer string. You can look at that. It's just a shell script. It's pretty simple. And then all of the commands actually go through to the dramatic command. So dash P means processes, 4 processes. So I'm going to start with 4 processes. Dramatic by default pulls as many workers, as many processes as you have available CPUs. But since I'm already using 5 CPUs to serve my web application, I'm only going to use 4 at the client. And there's going to be a little bit of contention here, but my gut is the C code is so much faster, it's not going to exhaust that very much at all, and most of the processing power is going to go to the client. So I'm not 100% sure about that. I could spend some time confirming that, but it seems like a safe assumption, and I want to put my time towards something that's more valuable. Oh, that's helpful.
What's dash D?
Ooh. That's interesting. What's what?
Dash D.
The dash P at the end?
No, I saw dash D earlier when you typed.
Oh.
In the document.
Up dash D means daemonize it, get it out of the way. This is problematic. Okay, let's try this. I have no idea. I tested this like an hour ago.
Docker compose logs.
Do what? Look at my Docker compose logs. Let me see if there's anything at the top that makes more sense. Nope. Okay. Well, I'll tell you what happened when you ran the workers. So when I ran the workers, I got no, that's not right. I was running 500 requests per second, or I was running 500 requests, and I was getting it was taking approximately 1.2 seconds, 1.6 seconds with the 4 processes working. So that gave me kind of a benchmark of what Dramatic could do. I upped that to 8 processes, and I believe it went to 1.2. So I did get a bit better performance with the processes. I could have updated, I could have kept bumping that up to 16, 20, 25. It wouldn't have helped me. It would have eventually started to create contention and clash between the processes, and it wouldn't have got any faster. It would have actually got slower. So I'm sorry I can't demonstrate that. So the next thing I want to do, so that method of parallelizing required a RabbitMQ server, and it required Dramatic, and it required that distributed task queue type setup. But there's lots of other options in Python for me to do some distributed work, some parallelized work, some concurrent work, without having to go through all of that setup. And so that's what we're going to look at next. Hopefully it'll work. So the first thing that I want to do is set up I guess I could have showed this earlier, but just to see what we're doing here. In order to fetch that request, we're using the request library. We're just making a GET request to it. It's very simple using the request library to do that, so we're not doing anything fancy. And just to show you that that works, let's go here and do flog, and then we'll do flog Falcon page, benchmark Falcon 25,529. So that was the counter. So now what I want to do is I want to run that, instead of just running it once, I want to run like maybe 500 of them at one time and see how fast that it does it. I'm not going to do that in sequence. If we did it in sequence, it would be one after the other, and we would have to make one request and wait again. Because this is all really fast and local, that it probably actually wouldn't take that long. But I don't want to do that. That's not what we're doing. I think everybody probably understands that. So the first thing I reach for when I'm trying to do concurrency and parallelization, I think there's actually a distinction there between those two terms. In my case, am I using, which one should I use? Is it concurrency in this case?
Yeah, so concurrency is when you're like thread switching or you're within an individual process using the same work. Parallel is when you have
Multiple processes.
or boxes
Okay, so concurrency is when you're in a single process, distributing work inside that process. Parallelism is when you have multiple processes on a machine or even multiple machines that you're distributing that work to. Is that right, Alex?
Yeah.
Yeah, okay. All right, so in this case, I usually reach for something that's built into the Python standard library called concurrent.futures. From my perspective, it gives me a very ergonomic, from a development perspective, a very ergonomic way to easily do concurrency, to kind of just get it out there. I may not want to tune it. I may not care very much. I just want to get something working, and I want it to be pretty simple, and I don't want the mental overhead of some of the other options that come along with different types of programming. So the first thing I'm going to do here is use a thread pool, which means I'm doing concurrency. And I just want to see how that performs with 500 requests. So I've set up a CLI command argument to take the number of workers, the number of requests as an argument, and then give me an option to change the number of workers. So let's go ahead and see how that runs here. I forget what I called it. Okay. Falcon pages. If I had done Falcon pages without anything, that was the dramatic code. So it is there. It does work if I can figure out why I'm not able to connect to RabbitMQ. So the first thing I'm going to do is try thread pool. Let's try 500 requests, and I'll just leave the workers as the default of 5. So Python is going to spin up 5 threads inside a single process. It's going to make 500 requests, and we're going to time that to see how long it takes that command to execute. Okay, so it took 3 seconds. That actually felt a little bit long. It's interesting. Okay, so it took 3 seconds to do it, 3.7 seconds to do it with threads. I'm going to do 5,000 just for the sake of argument. And I would expect it to multiply something like 10. Maybe I should have done 1,000 instead. Again, this is kind of like real world checking, right? Like it took 3.7 for the first one. Let's say I put 5,000 in there, and now it took like 10 seconds. I'm like, oh my goodness, like something else is hanging out my process then. Okay, 31. So I can be pretty sure there that most of that time is spent actually making those requests. So I'm going to back down to 500, and I'm going to see if bumping up the workers, I want to do let's do 10. So we were at 5. Now we're going to have 10 threads working at the same time, and see, I'm hoping that gives me about twice the effectiveness, so maybe I'm ending up somewhere at like 1.5 seconds. Workers, no. Well, that's actually kind of helpful because it shows me that just giving me an error takes 0.6 seconds. Wow, so the worker count didn't really seem to help us at all. We're still at 3.6. So let's, just for the sake of argument, let's bump that up to 50 and see if that makes any difference. Okay, so it made it a little bit slower. So that's either within my margin of error or it actually made it slower. So I'm kind of lucking out here. This is not doing what I wanted it to.
Instead.
Say it again?
Try it at 2 instead.
You want me to try it at 2 instead? Okay. So she's saying go down. See if that helps. Maybe a little bit faster within the margin. So it doesn't seem like threads are helping me a whole lot here.
Well, part of this too would be, I mean, to your point of knowing whether you're trying to optimize, and keep me honest, but as you're bumping that count higher, depending on what you're doing, you're also going to have all this allocation that's happening for these object workers every time, and depending on the life cycle of that, like you're actually introducing and so you would need to know the time that that's taking to actually.
Yeah, and what are they running on? Are they running on CPU or GPU? What's the architecture?
So I don't know any of those questions or answers to those questions. And for my purposes, I don't care. They're good questions, but remember what my goal is. My goal is just to get some benchmarks about what's possible with Python so that I can troubleshoot my real world problem. I just want to get a sense of where things lay. So that was threads. The nice thing about concurrent.futures is it has the exact same API to switch to processes. Oh my gosh. So I can switch to the process pool executor instead of the thread pool executor, and I can get processes instead of threads. So that's nice. I'm going to default that to 4, which is what I was testing Dramatic at. I was testing it at 4 workers, and I'm going to throw 500 at it and see if that, again, just kind of see where that falls. So we'll take the default workers, we'll use proc pool instead, we'll send 500. Okay, so now that seems a lot better. Now I've got 1 second. So my processes, multiple processes, so parallelization now is working better for me than threads were. Again, don't necessarily know why. Because of the GIL, yeah, that's probably why. I don't maybe know why, but it doesn't matter. It's just helping me to figure out what I can probably expect as I'm trying to troubleshoot my issue. So I'm going to go ahead and bump that up. Let's bump that up to 1500. Let's times it 3. Just kind of see. So I would expect something over 3. Wow, okay, so I actually only get 2 seconds. So there's some initial overhead in my command that I can tell that based on what I just ran. And let's go ahead and make that 5,000 now so that we get about 5 seconds worth of runtime here. Great, and so now I want to see if more workers help or hinder it. So I was at 4, let's go to 8. Okay, so not a whole lot better. I shaved off 1 second. If I'm going to max out all 8 of my CPUs to shave off 1 second, that may not be the best trade-off for me.
Couldn't you just plot it?
I could if I wanted to get that specific. Yep, I certainly could put some of this in a spreadsheet and start graphing it. But for my purposes, each time I run one of these things, I'm getting a better sense of what Python can do and where the slowness is and what method I should do for either concurrency or parallelization. So the last thing that I have here, I probably gave it away. What's the newfangled thing in Python for doing concurrency and parallelization? I guess it'd be parallelization maybe, or it wouldn't be. Actually, I don't know. It's concurrency? Okay. Async, yeah, async. And I think you might be able to use requests with async, but nobody recommends it, and you probably can't because it's not thread safe or whatever's going on. I really don't know what's going on under the hood. I use concurrent.futures. It works for almost everything that I need it for, and so I've not spent a lot of time learning the other stuff. But I did go out and find the quick start for this just to see what this gives us. So we were running 1500 the last time we ran it. We ran about 6 seconds. No, I think I was at 5,000, wasn't I? Dang it. Yeah, 5,000 with 8 workers. And so we had 5,000 with 4 workers, gave us about 6 seconds. So I'm going to run async against that and see how it works. Here's the async code if you're interested. One of the things about async is that you can forget an await somewhere, and you can have, I think this is true, you can forget an async or an await. One of them, I feel like you can easily forget it, and then you can have like mostly async code except for that one thing, and it's hard to troubleshoot. Is that true?
You could call a synchronous function, and different linkers and things are there to help you. But
Are they? Okay. Yeah. Okay, so the reason I use concurrent.futures and don't reach for async is because there's some mental overhead to understanding what's going on. And for my purposes, what I was doing, it just wasn't necessary. Now, if I'm going to go do this test and all of a sudden it 10x's the number of requests that I can get from concurrent.futures, then I probably need to stand up and pay attention. But if it only gives me a little bit, I may decide that extra little bit of performance, in my case, doesn't justify the mental overhead. But I've got to test it first to kind of see what it's going to do for me.
For something like this, like where this is more emulating like a client side, you might not be as worried about it. But for instance, if you're building something that is kind of your workload application, the other thing about async is you have things like UV loop. So async IO has this concept of a loop that Randy's getting on line 117. And there's people that are putting a lot of work into things like UV loop and other areas to get really high performance concurrency loops and context switching and everything. And so that is where you can see some substantial gains over something like concurrent.futures.
Great. So if you didn't hear him, he basically said if you were going to write more of a server application, there are other loops besides the default loop that people are building that you can import as Python libraries and use that for your main loop, and they're a lot more performant. So in some sense, we looked at earlier GUnicorn and the MineHeld worker, and MineHeld was built to be a really fast worker for GUnicorn. There's people who are building really fast loops for the async worker, or the async loop for async in Python. I'm saying async a lot. I need to find a different word, but I can't because that's what it means. Okay, so let's run this and see what it does here. Async 5,000. Okay, 4 seconds. That was as fast as my 8 worker version. So again, I don't know a whole lot about this. I don't work with a lot of concurrent or parallel processes outside of, we use Celery, which is kind of like Dramatic. It's a distributed task worker library. So as a guy who does a lot of programming, or has done a lot of programming, there's a lot of things I don't know. This happens to be one of them. But before I jump in and spend like 5 or 6 hours trying to figure out solution X, I just want to get a lay of the landscape, and I want to get a sense of what my performance characteristics are before I decide where I'm going to put my effort in. So at this point, if I was involved in this, I would probably say, concurrent.futures gave me pretty good performance. It's an easier to understand development model, but the threading version didn't work nearly as fast as the multi-process version did. I'm going to have multiple processes. On the other hand, the async code ended up working really fast comparatively with a single process, which might actually be better for my particular case. And now I got to start weighing things like, well, now if I actually go and start to look, well, am I writing the right type of client code? Would there be better ways to do this? Am I reusing HTTP connections correctly? Do I need to have some kind of HTTP connection pool that these things are sharing? And then I'm like, well, how do you do that in an async context? So there's plenty of questions that still need to be answered. But I'm at least, instead of, when I started this out, I just had this performance problem and I wasn't sure where to go with it. Now I've got some answers and I have a sense of what I can expect from my code, and I can start putting my research efforts into the right direction. And that was the sense that I wanted to give you here, is as a developer, how you can kind of jump around a little bit, use a little bit of testing here, a little bit of testing there, to start to put some benchmarks out there for you, or some bookends, and then within the bookends you can have a more productive use of time if you know, okay, I'm going to compare just these two things because I'm pretty sure I'm on the right track with one of them. questions about any of that, or about any of the code or what we've done here today? Okay. And I'm out of here in just under 45 minutes. Excellent. I'm on schedule. Okay. Thank you. Feel free to hang around, talk. Feel free to come up and ask questions if you have any, or chat too. I'm happy to do that. Thanks for coming tonight, and have a good evening.